Okay, so I think I mentioned it yesterday, but the purpose of today is kind of like a review, to review the 3 different methods we've learned to solving systems, but also to talk through a little more why we've got 3 methods and when one method might be easier than another method. So I keep using the word method. We've learned 3 different ways to solve systems. What are those 3 different ways?
Graphing, substitution, and elimination.
Substitution and elimination. Perfect. In order to use graphing, what would we do?
If you have a graph, you can either just use the equation as it is or like break it down to get it to y-intercept form.
Slope-intercept form.
Or slope-intercept.
So to graph, we would need both equations in slope-intercept form. We might be given them that way. We might need to solve for y to change them into slope-intercept form. Then when we have that, what do we do?
Then you plot each equation onto the graph and figure out if the lines intersect.
Beautiful. Graph both lines, find that intersection point. That would be our solution. For substitution, what would we need to do in order to use substitution?
Generally, either y or x will equal something, and then you can use that equation to input it into another equation to solve for x and y.
Yeah, I was about to say, you're sounding like a teacher. So generally speaking, that would be good if we have x equal to something or y equal to something. If you have one of those, you can substitute it into the other equation. You would solve for one variable. Then more often than not, substitute again to find the other variable. And then elimination, what's that one look like?
You'll get it so that one of the variables will be the same number but different signs so that you can eliminate it to make the equation smaller so that you can...
Smaller and only one variable.
Yeah.
So you said we want to get it to where the variables have the same number and different signs so that they eliminate. You said we want to get it. How could we get it to do that?
You can do that with multiplying, with subtraction,
Addition. Yep.
addition.
Using an operation to help make that happen. Beautiful. What a great summary. So I've got 3 questions we're going to look at, 3 systems. Each time I have given us a graph, you had mentioned with graphing, if you have a graph, so it's there as an option. Each one of these, I have a method in mind that I think would be the easiest way to solve it. That said, this system right here, how do I want to ask this? Can you use graphing to solve it at the end of the day?
Yes.
Can you use substitution to solve it?
Yes.
Elimination?
Yes.
Yes. Any single system you can choose. I want to keep emphasizing that. If I asked you, how do you want to solve it, and you told me elimination, and I'm thinking substitution, you're not wrong. I just have a specific thing in mind that I think would be the easiest way to solve, which is what I want to focus in on today. So we've got this system here. You've already told me we can use any method we want. Looking at this system, which method do you think would be the easiest one to use?
Probably graphing.
Tell me why you're thinking graphing.
Because they're both already in slope-intercept form.
Yep. We've got them in slope-intercept form. We've got y equals mx plus b. That is very nice when you're graphing. You don't have to solve anything first. They're just ready for you to graph. I also think graphing would be easier. One of the things you mentioned earlier was for substitution, we need x equal to something or y equal to something. That's also true here. So why did you say graphing and not substitution?
Just because they both are in slope-intercept form. Seems like you can just put them onto the graph really easily.
If I wanted to solve this by substitution, what would I need to do?
You would take one of the y equals and put it into the other one.
So if we did that, that would give me
Negative 3 over 4x plus 5 equals 1 over 2x minus 5.
Nice one. And then what are we going to do with this line? Generally speaking, what are we going to do with what we're looking at now?
Just get the x on one side.
Yep, and solve the equation.
Mm.
Is this an equation you are just dying to solve? Why not?
It's got fractions.
Yeah. So that's the other piece to this. I agree, graphing, they're already in slope-intercept form, which makes it really easy to graph. But that extra thing about fractions, when we're graphing things, if it has a fraction, it's really like no big deal because it's very easy to graph fractions when they're your slope. But when it comes to solving equations, I am very confident in my ability as a math teacher to do math with fractions, but even I'm looking at this like, it's probably not like my ideal thing I would want to solve. So that, I think that combination of what we've noticed, they're both in slope-intercept form. And then when there's fractions graphing, it's no big deal. Solving, it's no big deal, but I don't think this is anyone's ideal thing to do, even a math teacher. So you told me what we're going to do. We're going to solve this by graphing. I'm going to probably take us through the rest of this myself, but I'm going to have you graph, if that's okay. You want to come up and solve it by graphing?
Okay.
And we figured out that this marker, I think, is the dead one, so don't use that. Use this one.
So for the first one, you start at 5, so that's 1, 2.
Mm-hmm.
You start at 5, it's negative 3 over 4, so go over, or because it's negative 3,
Mm-hmm.
x and y, so you do go over 3, and then up 4.
How do you find slope from a graph? There's a formula we use.
mx,
No.
Well, rise over run.
Okay. So you can use that to help tell you what to do. We want to rise negative 3, and you've already said negative means we're going to go
Down.
Uh-huh.
So it'd be 1, 2, 3,
and
and
then,
over 4.
yep.
1,
Yep.
2, 3, 4. So
Mm-hmm. You're right. Yep. And that's probably enough if you want to draw the line through that. When it comes to graphing two lines, I always recommend once you've got the points for the first line, draw your line before putting more points down, because I have done that before and confused myself. We've got the second one.
so that one starts at negative 1,
Mm-hmm.
and then it goes up 1 over 2.
Mm-hmm. Did the teacher do something wrong? One, two, three, four, five. Uh-oh, Samantha, what did you do? Well,
I mean, they still intersect.
they are. And this is a perfect example of the fact that they're not always going to be beautiful solution points. We had talked about that in one of the previous lessons. I think it was yesterday's lesson, how sometimes you can get fractions and decimals in your solution point. We're going to make this a learning experience. I did not mean to give us this fun solution point, but everything is all good. But let's talk through it. So can I look at this? I can tell it's not intersecting at a beautiful location. When it comes to graphing, we have an idea of what number that might be. Like I'm seeing 1, 2, 3, 4, somewhere between 4 and 5. A lot of people here, it's between 4 and 5, 4.5. But when it comes to a graph, we don't know what that fraction is. We know it's somewhere between 4 and 5, but it could be 4.5, it could be 4 1/3, it could be 4 9/10. We just know it's between those. So, thank God we've got other methods. Let's go ahead and solve it with substitution, and we'll see what that actual fraction is. I've planned all of this. So we're looking at this equation with fractions. You can absolutely go through and solve with the fractions in it. We looked at a strategy last week, though, to get rid of the fraction. Do you remember what that strategy was?
Not really.
When it comes to these fractions, if I didn't want it to be a fraction anymore, I need to take away that bottom number. That's what's making it a fraction. I read this part here as like 3/4, but you can also read it as 3 divided by 4. If we want to get rid of the divided by 4, we need to do the opposite, which is multiply by if you want to get rid of divided by 4.
Multiply by 4.
Yeah. Here we've got 2 different denominators. You can either multiply both sides by 2 to get rid of this fraction first, and then if you need to, multiply by the other one. What's going to happen here is if we multiply by 4, it's going to take out both of those fractions because I could change 1/2 to 2/4. It's going to get rid of both. So I'm going to come in and multiply both by 4. When I do that, let's start over here. What's going to happen there?
It's going to cancel out.
So those 4s will cancel, which leaves us with
Negative 3. So it would be,
Yep. And then
it would be plus 20.
equals, over here, 1/2 times 4.
2.
Nice. 2.
X
And then
equals,
we already got the equals.
minus 4.
Yep. Okay. So we're left with this equation here. Now it's much nicer looking. Still going to give us a fun answer at the end, but it's okay. Looking at this, what would my next step be?
Get one of the x's by themselves.
So which one do you want to get rid of?
4. Negative 3.
Okay. How are we going to get rid of that?
Divide negative 3x.
We're not dividing. If you divide by negative 3, it's just going to give you,
Or no, so g.
we want to take out the entire term. So the opposite of a negative 3x.
Positive 3x.
So we're adding 3x on both sides. When I do that,
That would cancel out, and then be 20 equals 5x minus 4. And then from there, add 4 on both sides.
which is going to give me
24 equals 5x. And divide both sides by 5. You get
x equals.
4.8.
Look at you. That's great fraction division. I was thinking you were just going to leave it as 24/5, but it does equal 4.8. Going back to what we said earlier about the graph, we had mentioned earlier it was between 4 and 5. I had said lots of times people want to just assume it's 4.5 or 4.5, but this is a perfect example of why you can't make that assumption. That is only half of our answer. This problem just turned into a real fun one, didn't it? Let's hope I didn't mess up any other ones. But it's a good example. This can happen. This is a very real question. It's just not the one I was intending for us to do right off the bat. We've got the 4.8 or the 24/5, however you want to think of it. The idea is the same. We want to substitute it into one of these. Again, looking at the graph, we can tell this point is between 1 and 2, but we're not exactly sure what it is. I'm going to suggest, because the equations we're using already have fractions, I'm going to substitute the fraction form, although I do like the decimal form for our final answer because it's like we were saying, I can tell it's between 4 and 5. So let's substitute 24/5. Which equation do you want to substitute it into?
Probably the second one.
I agree. Is there any, could we use the first one?
Yes.
I agree, though. I'd rather multiply it by 1/2. So 1/2 times 24/5 minus 1. This is a great opportunity to review how you multiply fractions. Do you remember how to multiply these together?
Do you multiply them like?
That is if there had been, if it was like an equation like that. To solve an equation, you cross multiply. If you were just multiplying fractions together, you're just multiplying straight across.
Okay.
So I would do 1 times 24.
Should be 24 over 10
Mm-hmm.
minus 1.
Now to subtract that, I think our best bet is to divide this. Do you know what that's going to give us?
Well, couldn't the answer be 24 over 10 minus 1? Couldn't it be changed to like 14 over 10?
Mm-hmm. That's another way to do it. So we could say 24 over 10 minus, instead of 1, thinking of it as 10 over 10. And that would give us 14 over 10. That's also a perfect way to do it. 14 over 10. Do you know what that one is?
Could be 1.4.
You were really impressing me with these fractions and decimals today. 1.4. Again, we said we could tell from the graph it's between 1 and 2, but now we know exactly what it is. So we've got 4.8 and 1.4. I have not hidden the fact that this is not the problem I meant for us to do, but I think you did a great job with it. And at the end of the day, if you can do ones with crazy fractions and decimals like this, I think you can probably do the easier ones. Thank you for your patience at home. The rest of this should be much easier, unless I messed up again. I should not create math problems late at night. Let's try this one. So again, we said at the beginning of this, there's 3 options. You could use all 3 options. Looking at the system, which one do you think is the best one to use?
Probably substitution.
Tell me why.
Because there's an x equals something
Mm-hmm.
you could put into the second equation.
Yeah. If we had wanted to use graphing, it would have involved us changing both of these into slope-intercept form. When it comes to elimination, when you are adding or subtracting equations, it looks kind of like they're all on top of each other ready to add up, but notice those equal signs are in different places. So we would end up having to move something over so that, for example, for this equation, x and y are both on this side. We would have to move the y over so that it's the same, and x and y are on the left side for this first equation. And then we would have to change it so that's something eliminated. So you could still do it, but there's a lot more steps. You notice we already have what x is, which means it's all ready to go for substitution. So if x equals 2y minus 3, what are we doing for that?
You do negative 3 parentheses 2y minus 3 plus 7y equals 9.
Beautiful. Now what?
And then from there you distribute the negative 3, so it would be negative 6y would be plus 9?
Mm-hmm. You got it.
Plus 7y equals 9. And then from there, you want to get one of the y's by themselves.
Mm-hmm.
So, could add 6y.
Notice here the y's are on the same side of the equation. If they're on the same side, what does that mean we can do?
Oh, you can combine them.
Yep, combine like terms. So I'm going to combine negative 6y and positive 7y.
Which would just be 1y or y.
Yeah, 1y. And we don't need that 1, so y.
Plus 9 equals 9. So you subtract 9 from both sides, and y equals 0.
Nice. So we get our y equals 0. Final answer?
No.
I've asked that so many times. You're so good now. We've got y is 0.
And then you can put 0 as y into either equation.
Mhm.
The top one is less numbers. So you
I
can do
agree.
that one.
Yep. 0 is also a real easy one to do in your head. If there ever was a number you do in your head, 0 is the easiest one, I think, to do. If we put 0 here, 2 times 0.
Be 0.
Yep, it's kind of like that's just canceling out.
So x equals -3.
Yep. Ta-da! This is so much easier after that last one. I'm going to ask it again. If we ever wanted to check an answer, I did not want to check that last one. But if this would be a great one to review, how would we check our answer here?
You put -3 and 0 into x and y.
Mm-hmm.
You can do that for either equation.
Mm-hmm.
For the bottom one, put -3 into -3, makes it 9.
Mm-hmm.
And then plus 7 times 0, which is 0,
Mm-hmm.
equals 9. And 9 plus 0 equals 9.
Yes, that lets us know our answer is all good to go. What I like you did is, since we used this one to figure out what 0 is, you checked with the other equation. I think that's a good strategy. We could also check with this one, but this is a good sign that we've got it right. I've got one last one for us. The last one looks like this. Got the system 4x minus 3y equals -5 and 3x plus 6y equals 21. Again, we can choose any of these options. Which one seems like it would be the easiest option?
Elimination.
Tell me why.
Because you could multiply the top equation by 2.
Where is that 2 coming from?
I guess it doesn't really come from anywhere. It's just kind of
How did you know you wanted to multiply by 2 is what maybe I should ask.
because they're both over each other in order,
Mm-hmm.
I guess. So it's like variable
Yep, x,
order
y
variable
equals a number. Mm-hmm.
So
This, by the way, we learned this back in Algebra 1A, but we don't talk about it often. This is called standard form. Standard form. Oftentimes we talk about slope-intercept form, the y equals mx plus b. This is another form in math. We don't use this one nearly as often as slope-intercept form, but it does have a name. When you've got x, y equals a number, standard form. So you were telling me they're all lined up in standard form. How did you figure out we want to multiply by 2?
because there's a 6y on the bottom and a 3y on the top one,
Mhm.
and 2 times 6, or 2 times 3 equals 6.
Yeah, so you figured out this is the number we would need to multiply by to make them
Mhm.
look the same.
And the bottom is a positive, and the top would be a negative.
I like how you added that in, and we've already got different signs. Is this the only option in order to use elimination?
No.
No. Do you know another way we could do it?
You could also multiply both equations.
Mm-hmm.
The top one by -3,
I'll put this option over here, -3.
and then the bottom by 4,
Yep, so why did you go with this instead of this?
because it's less multiplying to do.
Yeah, we always like less multiplying. Again, they're one of the reasons I love systems is because there's so many different ways you can do this. I'm just trying to steer you towards the easiest way. At the end of the day, though, easiest is very subjective. It's very personal. I said elimination is the easiest way, but if you don't know how to do elimination, it's not the easiest way. But it will require the least amount of steps. So you told me we're going to multiply by 2. Would you like to take over?
Okay.
Such a good sport. Did I steal your marker? Is it? Okay, it's okay.
Yeah. Okay, so what you do is you distribute the 2,
Mhm.
so it's 8x minus 6y equals -10. And you don't do anything to this, so you just bring it over 3x plus 6y equals 21, and then you do the math. 11x, this is canceled. equals negative 10, 21, 11.
Mm-hmm.
Divide both by 11. X equals 1.
Mm-hmm.
And then from there, you can, to find y, you can plug this into either one. I'll just do the bottom one. So that would just make it 3 plus 6y equals 21 minus 3, both sides. 6y equals 18. Divide both sides by 6. Y equals 3.
Perfect. It looks good. The only other thing I wanted to add in for this is I was grading the homework on elimination last night, and there was 2 students who mentioned when you're using elimination, you had said earlier when I asked you, like, how do you get equations to eliminate? You mentioned we can add them together, we can subtract them, you can start off by multiplying an equation and then doing that. And 2 people on the homework pointed out you can also divide. So if I wanted to, instead of making them both 6s, make them both 3s, you do have another option of going in and using division. Instead of making the 3 into a 6, you can make the 6 into a 3 by dividing everything by 2. The reason we recommend multiplying instead of dividing is not always, but a lot of the times when you go into divide, not all 3 of these are going to be divisible by 2. So this is a beautiful example of you can divide by 2 and you will get that 3y that you need to eliminate the y's. But here, you're going to get 1.5x. And then over here, 21 divided by 2 is 10.5. I think it's safe to say we had like enough of the fractions and decimals with that first problem. But you could keep solving. I mean, this is a very real and possible way to solve the system if you wanted to keep going and just do it with the decimals. It's perfectly fine. At the end of the day, division, something like dividing by 2, division can be rewritten as multiplication. Dividing by 2 is the same thing as multiplying by a half. Like I could say I'm going to divide 6 by 2 or multiply this equation by a half. So division is technically multiplication. That's a weird thing to say. Division is technically multiplication, but division can be rewritten as a multiplication problem. But the reason at the end of the day we usually look at the smaller number and see to make if we can make it look like the larger number is because this way isn't going to give you fun decimals and fractions.
Yeah.
But I thought it was a really cool thing that people pointed out in the homework. So thank you, people at home, for bringing that up in the homework. Questions on any of these methods or deciding which, I think you did a really great job of deciding which way is the way I would probably recommend doing it. Then the only other thing we've got this lesson, I tried keeping it short, is because we've got an activity on Desmos. Do you remember doing any of the homework assignments on Desmos last quarter?
I think so.
I think it'll look familiar once you go in. It is on Google Classroom. It's similar to this where there's a couple questions where they're going to ask you, like, which way would you solve this system? Would you use substitution or elimination? And then it's got some practice ones where you match the cards. You match the system with the solution.
Oh, yeah.
You remember now? Yeah. So this is where I'm going to stop the video because you can go do that activity now. Goodbye. And if you want